Dynamic arrays are a revolutionary way to model. This video demonstrates how modelling with dynamic array formulas is very much like, and even easier than, modelling with traditional formulas. Roughly 70% of the formulas will need only a minor change to switch from range references to dynamic array references. This switch sometimes shrinks the original formulas. Roughly 10% of the changes will require Excel's sequence and choose rows functions. The remaining changes will require 5G functions. 5G functions are much easier than the formulas they replace. Here is where we start, a traditional three-statement model based on the FAST methodology. FAST is designed for non-technical modelers. 5G is also designed for non-technical modelers, but works with all modelling methodologies. We start by importing our 5G libraries. The libraries are in the Financial Starter Pack. To import them into our model, we simply copy any worksheet from the Financial Starter Pack workbook into our model, then delete the worksheet and close the Financial Starter Pack. That copies all 5G functions into our model. The next setup task is to add two inputs to MPC. The first input is model periods. This entry makes it possible to eliminate all the copy to write steps for every calculation row. The second input is for period interval. I'm adding this step to implement the best practice of removing all hard-coded values in formulas. In this case, I want to eliminate the hard-coded 12 from formulas that convert annual inputs to monthly values. Let us move on to NPS. NPS is designed for entries by period. These entries are static ranges. For consistency, we want them to be dynamic ranges. To convert them to dynamic ranges, we use the 5G function, range to DA. Let us move on to time. Our first change is to bring our new input, model periods, into this worksheet. Using model periods, we turn our model column counter into a dynamic array using Excel's sequence function. The next several changes are nothing more than replacing the range reference in column J to the simpler dynamic array reference. On row 19, we replace the EO month function with the simpler EDate function. In row 23, EO month makes perfect sense. We use sequence again in row 35. The rest is converting column J references. We are now ready to move on to the Calcs worksheet. It is not until we get to row 50 that we need a significant change. Here we replace Excel's sum function. Sum does not work as we want it to with arrays, so we use the 5G function, sumcols, instead. In row 66, we replace a fairly complicated formula with the 5G function, rolling sum. Rolling sum is used in the depreciation calculation to depreciate assets purchased in the prior 4 years. In row 71, we introduce 5G function, corkscrew. This one function in one cell replaces 3 or more formula rows to calculate opening and closing balances. In row 85, we leverage 5G function, movement. Movement calculates the differences between columns. We use movement again in rows 94, 99, and 107. In row 115, we use sumcols again. And in row 123, we use corkscrew again. Starting in row 138, we replace the entire debt section with a 5G functions called amortize. This one function in one row replaces 6 formula rows. It calculates our debt issuance, debt balances, interest expenses, and debt repayment. In row 152, we use Excel's choose rows function to pull one or more rows from our two-dimensional array produced by our amortize function. In row 153, we use sumcols again. In row 154, we replace Excel's max function, which does not work with dynamic arrays as we expect it to, with this formula. Row 165 uses corkscrew again. Rows 176 through 178 use choose rows. Row 179 uses sumcols. And in row 181, we use corkscrew one more time. Once again, most changes are reference changes. Wherever sum is used in column J, we use sumcols instead. Where the old range references point to a row that is now within a two-dimensional array, we use choose rows instead. Wherever a corkscrew calculation exists, we use corkscrew instead. Again, most changes are reference changes. we replace sum with sum cols. We replace corkscrew calculations with the 5G corkscrew function. Lastly, we make reference changes to our integrity checks. That's it. In roughly 10 minutes, we converted this traditional model to a fully dynamic array model. While it may seem that we have not made any real improvements, we can celebrate that our model's potential failure points has been dramatically reduced. Wow. This is due to dynamic array's spill range. Spill ranges have results, but no formulas. Thus, our model's formula count is a tiny fraction of the original model's formula count. But we are not stopping here. We have some functional improvements to add. We start by simplifying our time worksheet. To maintain best practices, we move rows that we will need in other calculations above those calculations. Next, we will leverage a 5G function, timeline. This function creates a dynamic timeline that we will find useful in a bit. Our timeline function can calculate period end dates as well as period start dates. From period ends and period starts, we can calculate days in a way that accommodates different period intervals. We also simplify how we calculate model year. We now turn our attention to removing the hard-coded 12. This requires calculating the number of model periods in a year. This calculation also supports changing timeline intervals. Lastly, we use that calculation to simplify how we calculate our annual timeline. By making these changes, our model can now show results by month, quarter, or year. That makes the separate annual statement redundant.